absolute functions. Let's try to solve the equation involving two absolute functions. Question is, solve for x when absolute 2x minus 6 minus absolute x plus 2 equals to 0. Now to solve such equations, it is better to rewrite the absolute function in terms of its piecewise function. What I'm trying to say here is that absolute 2x minus 6 could be written as equals to 2x minus 6 if 2x minus 6 is greater than or equal to 0, and it is equals to minus of 2x minus 6 if 2x minus 6 is less than 0, right? Now we could always write this as equals to 2x minus 6 if, let's take 6 on the other side, then we get x is greater than or equal to 3, or it is minus of 2x plus 6 if x is less than 3, right? So that is how we can write absolute 2x minus 6 as a piecewise function, right? Remember, it divides the interval of all real numbers into 2 at x equals to 3. Similarly, for x plus 2, we can write absolute x plus 2 is actually equals to x plus 2 if x is, when is this 0? At minus 2, right? So greater than or equals to minus 2. Or it is minus of x plus 2 if x is less than minus 2. So that is how we can write the absolute function x plus 2. Now let's solve this equation in these intervals. So the intervals which we get really are, let's write down here. So we get, to solve this equation in the interval from minus infinity to minus 2. So let's say this point is minus 2 for us. And then between minus 2 to 3, let's say this is 3 for us. So in these three intervals, we should solve our equation and then find the answer, right? So let's do the case 1, which is when x is less than minus 2. So when x is less than minus 2, then the equation becomes, if x is less than minus 2, x plus 2 is minus of x plus 2. And when x is less than minus 2, 2x minus 6 is also minus of 2x minus 6. So we have this equation as minus of 2x minus 6 minus, and x minus 2 is also minus of x plus 2, correct? Equals to 0. So that is the equation which we are trying to solve. So what do we get from here? We get minus 2x plus 6. Now that becomes plus, so we have plus x plus 2 equals to 0. Or we can write from here x is equal to, so we'll take 2x on this side, so it is minus x is equals to 8. So x is equal to 8. But x equals to 8 is not in the interval x equals to minus 2. So that is not a valid solution, right? So not valid. So we'll ignore this solution, right? So let's go to case 2 now. So case 2 is when x is between minus 2 and is less than 3, okay? So we know minus 2 and 3 is not the solution, right? When I write minus 2, then one of them is 0, not the other one. And at 3, the first one is 0, not the other one. So these two are not part of our solution. So let's look for the interval between minus 2 and 3. Now if we are in the interval minus 2 and 3, then 2x minus 6 is indeed negative of this value. So let me write down straight away the negative of this, which is minus 2x plus 6. That is how the first term is going to be. Negative of if we are greater than minus 2, in that case x plus 2 is, absolute value of x plus 2 is x plus 2. So we get minus of x plus 2 equal to 0. Let's solve this now. So we have minus 2x plus 6 minus x minus 2 equals to 0. That gives us, it is minus 3x and 6 minus 2 is plus 4 equals to 0, or it gives you a value of x equals to 4 over 3, right? Now 4 over 3 is in this interval of minus 2 and 3, so that is correct solution, right? So this is okay for us. Now because we are running out of space, let me take case 3 on this side. So case 3 is when x is greater than 3. Now if x is greater than 3, then both the values are positive. And so we can write down our equation as 2x minus 6 minus of x plus 2. So I'll just open the bracket and write it as minus x minus 2 equals to 0. Now this could be solved as 2x minus x is x, and minus 6 minus 2 is minus 8 equals to 0, or we get x equals to 8. Now x equals to 8 is a valid solution. It is greater than 3, so that is a valid solution, correct? So we get two solutions for our equation, and therefore we can write down our answer. And our answer now is x is equal to 8, or x is equals to 4 over 3. So that becomes the solution set for the given equation, right? So I hope you understand the method and you appreciate how we did it. Now let's go through it once again. Now whenever you have absolute functions, it is better to write them as a piecewise function. So I took time here to show you how to write absolute function as a piecewise function. So absolute of 2x minus 6 could be written as its positive value if 2x minus 6 is greater than or equal to 0. That means x is greater than or equal to 3. And its negative of this if it is less than 3. Similarly, x plus 2 could be written as x plus 2 if x is greater than minus 2, and negative of this if x is less than 2. Now that gives us three different cases to solve. One is in the interval of minus infinity to minus 2, the other one is between minus 2 to 3, and the third one is from 3 to infinity. So we solve these three cases separately and check our solution. The first solution was x equals to 8, but that is not in the interval of x less than minus 2, and therefore it was ignored. The second solution was x equals to 4 over 3, which is indeed in the interval of minus 2 and 3, so it works. And in the third interval, case 3, was x greater than 3 when both values are taken as positive, and then when we solve we get x equals to 2, which is again a valid solution. So we get two solutions for this absolute function equation, and these are x equals to 8 and 4 over 3. I'd like you to verify by substituting these values into the equation and check for yourself, are they the right solutions or not? Thank you and all the best.